matter experts, and all participants. Good day, the program chair, professors, subject matter experts, and all participants. My name is Mr. Samuel Acheme from Edo State University, Uzare, Nigeria. I will be presenting a paper titled A Crypto-stego Distributed Data Hiding Model for Data Protection in a Single Cloud Environment. We've seen how the traditional social and economic activities are gradually giving way to a system of interconnectedness. And these activities are facilitated by various species of cloud infrastructure and associated services. These services have been of immense benefits to individuals, businesses, and organizations. However, they have brought a lot of security challenges. So consequently, users are putting in place different measures to protect themselves in the cloud. And steganography is one of these measures. As a background, we'll look at data breaches, which is a situation where sensitive and protected information is exposed to an unauthorized person. We look at steganography, which is a technique of hiding a sensitive information behind a visible file. We look at cloud computing, which is a model that offers on-demand and convenient computing services to users, hosted and accessed through the internet. And we look at steganography in the cloud, which is a data protection technique where sensitive information is hidden in a visible file before being saved in the cloud. Now we look at the problem statements here, which is that cloud providers are regularly reviewing and upscaling their security protocols to protect data. But data protection in the cloud is not just the responsibility of the service providers. And so users have also put in place measures to protect themselves. And steganography is one of these. However, there are certain limitations to the existing techniques, and there's a need to study their performance and find innovative ways to improve their data protection capability. And in this study, the purpose of this study is our aim is to understudy the existing data protection strategies in a single cloud environment using steganography in a bid to ascertain any gaps consequent upon which we propose an improved model for data protection. And then we consider some research questions in this study. The first is, to what extent is steganography relevant in the scheme of confidentiality and integrity as applied to the security of information infrastructure? And then we check whether or not steganography finds useful application in the cloud environment. And how has the available steganographic algorithms fared in the last decade, especially in the face of emerging cloud deployments and data breaches? And then, are there any innovative ways to strengthen existing steganographic algorithms in a bid to contain the rising spate of data breaches in cloud deployments? And then methodology. In this study, we consider two models. The first is the three-step data hiding model proposed by Pandit 2015, where the hidden message was encrypted using the RSA algorithm, where the message will be hidden an image using steganography and then saved in the cloud, deciphered, recovered, and then deciphered to get the message back. And then the second model here is the distributed data hiding model in a single cloud environment, proposed by Chentio et al. 2021. Here, the hidden message was fragmented, and then it was hidden in different cover folders in the cloud environment without cover media modification. They noted that modifying cover media to hide secret message leave traceable fingerprints, which can trigger steg analysis attack. So they proposed an improved steganographic algorithm whereby the cover media wasn't modified, thereby improving the imperceptibility of distributed steganography. And then this is our proposed model, and it's a crypto-stego distributed data hiding model for data protection in a single cloud environment. In this model, we incorporated the RSA algorithm into the existing distributed data hiding model in a single cloud environment, thereby, modifying the stego key. In this model, we encrypted the message, we fragmented the cipher text before hiding in different cover folders in the cloud environment. And then for recovery, we had to extract the message and then decrypt again using the RSA algorithm. And this is the structure of the proposed model. This is the first step, which is the RSA key generation. And the algorithm is taking an input of two large prime numbers and then an output of public key and the private key. And then this is the RSA encryption algorithm, which is used to encrypt the message to be hidden. And then this is the embedding algorithm, which will be used to which was used to hide the message. And this is the algorithm for recovery. And this is the RSA decryption algorithm. And then in the implementation of this, we adopted a use case methodology, and it showed how an improved data concealment strategy can be employed in the cloud. The use case is a short secret message 10101100 in base 2, which is equal to 172 in base 10. And then the workflow show how the Crypto-stego distributed data hiding model in a single cloud environment was employed. And this is the result of the RSA key generation program. And then this program shows the result of the encryption, where the plain text was encrypted to get the cipher text. And then this shows the binary conversion of the secret message, where the cipher text was converted to base 4, which is the base we chose in this study as the embedding base. And then this figure shows the arrangement of the files in the folder. These are the different files in the folders that we chose to host the hidden message. This shows how the files were set up according to their index. And then this shows the folders with their different files. And this shows the folders with their different files. And the highlighted folders here shows where each fragment of the hidden message will be saved. And then this table shows how the stego folder was generated, which is a unique folder that contains only stego files. And this shows how they were arranged according to the index of the folder and the index of the fragment of the hidden message. And then for recovery of the hidden message, in this study, two keys were used, which is the public key, which was used to hide, and then the private key, which was used to recover. And then in the public key, we have the class storage credential, which contains the username and password, the embedding base, and then the RSA public key. And then for recovery, the class storage credential, which is the username and password, the base used, and then the RSA private key was used for recovery. And then here, this table shows how the hidden message was recovered by moving across different folders according to the using the embedding base and then the index of the hidden message. And then this shows the conversion, how the different fragments of the hidden message was put together and converted to base 10. And then here, after putting together the different parts of the hidden message, which is a cipher text, it was converted to the plain text using the RSA algorithm. And then this table shows the comparison of our proposed model to the existing model based on the stego key. In the existing model, one stego key was used for encryption and decryption, containing the class storage credential and the base. In our proposed model, we use two stego keys, one for embedding, one for recovery. The one for embedding has the class storage credential, the embedding base, and the RSA public key. The one for recovery has the class storage credential, the embedding base, and the RSA private key. And then we continue our comparison here. In the existing model, there was cutting of stego files. In the proposed model, there was no cutting. In the existing model, one stego key was used. In the proposed model, two stego keys were used. In the form of the recovered file, in the existing model, it was a plain text. In the proposed model, it was a cipher text. And then the components of the stego key. In the existing model, it was cloud credential and embedding base. In the proposed model, it was cloud credential, embedding base, and RSA public and private key. And then we continue our comparison using two hypotheses. The first is that there's a spy in the cloud environment. In the existing model, if there's a spy in the cloud environment, there are more chances for secret communication to be noticed because of the cutting and deletion of files. In the proposed model, files are not cut and deleted, rather they are being moved, thereby making the cloud environment the same before and after secret communication. In the second hypothesis, there exists a spy in the cloud environment who has the stego key and is aware of secret communication in the cloud. In the existing model, there are more chances for the spy to recover the message because only one stego key was used. Meanwhile, in the proposed model, there are less chances because even if he has the stego key, it's impossible because two stego keys are being used and only the private key can be used for recovery. In conclusion, the recent distributed data hiding model in a single cloud environment improved the imperceptibility of distributed steganography. And this study improved this model by adding an extra security layer. The novelty of this work is the introduction of the RSA algorithm into the distributed data hiding model. And secret message is more resistant to detection and recovery. For recommendations, for future studies should focus on the applicability of this model to a multi-cloud environment and also on increasing the complexity of the stego key. Thank you for listening.